Right, hello everyone. In this session, I want to look at something called GraphQL. My name's Sandeep, and I'm a software consultant based out in England. Just before we get into this session, has anyone heard of GraphQL before they've come to this talk? That's pretty good. Is anyone using it in production? Okay, maybe not so good. Okay, awesome. So it gives me a point of where we can go with this talk. So let's have a look at the agenda. This is what I want to cover today. So the first thing I want to look at is the considerations and challenges that we have when we create APIs today. Then we'll have a look at what GraphQL is, what it's not, and what it aims to solve. Then we'll take a deeper look into what GraphQL's core concepts are and principles. And then there's going to be a demo where we'll build a GraphQL server, as well as hook it up to a single-page application to kind of give you a real-world example of how you could use it. Then finally, I want to go through some considerations around when to use GraphQL and some of the not-so-good things about GraphQL. Right, so there's various technologies that facilitate server-to-client communication. Here's a list of some of them that you might have seen before or used. It's REST, SOAP, RPC, and OData. And there's various other ones which I haven't put on. But the whole point of this talk is we're going to compare how REST is to GraphQL. Now, I've just got to give a little bit of a disclaimer. This is not going to be a talk about saying REST is poor and GraphQL is the best thing since sliced bread. It's not going to be like that. I'm going to try to give you an informative and unbiased opinion about the goods and bads of both technologies. So I just wanted to say that first. Right, so I just want to quickly recap on some of the core concepts of REST. So REST is an architectural style, and it's a pattern. It's not a framework or a library. It's based on this concept of resources. And we name our resources using nouns. So for example, we've got API patients, and patients is our resource. And because we use REST over HTTP, we have these HTTP verbs and operations which allow us to mutate our resources. So we can basically manipulate, we can get, put, delete, and post. And one of the most important things about REST which is argued quite a lot, is a hypermedia constraint. And the hypermedia constraint is ultimately about having links in your resource representation that provide links to other related resources. It's kind of like transitioning from state to state. So for example, if we had the API patients endpoint / with an ID, say 1, in that representation we get back in our response, we might have links which are hrefs to things like medications, allergies, and various other things related to that patient. So this is what I mean by REST, and this is what we mean roughly by REST throughout this talk. So it's just a little bit of context. Right. So when we build APIs today, there's various things that we have to think about. There's some challenges and some considerations. One of them is around efficiency. How efficient is our data retrieval? How many requests do we make to a server to get all of our data requirements back? Next is around predictability. Do we get the response from the server that we expect? And there's an interesting topic around versioning. Versioning is one of these things that has kind of had various implementations and ways of doing it. Some are more correct, some are more RESTful, and some are not. So how are we doing versioning? Are we evolving our APIs? Or are we using things like version numbers in the URI, or sending stuff in the headers? Then there's things around caching. Are we utilizing network caching? Have we got caching on the app server? Do we cache on the client? There's various things around security, tooling, platforms, and documentation. So now I want to have a look at an example. So what I want to do is I want to walk through this example, which is a very simple view. It's a single patient view for a patient in a medical system. So it's composed of 3 parts. So there's the summary, which kind of gives you a name, date of birth, an identifier, and basic information like that. Then we have medications that the patient's on. Then we have allergies, so things that the patient is allergic to. So what I want to do is I want to walk through this example and see how we'd fetch the data for this, and some of the challenges we face when we're going to fetch the data for this if we're using REST. So the first thing is, if I was to request the patient's endpoint, I would technically get back, if I've implemented the hypermedia constraint correctly, I would get links to other resources. And these would be medications and allergies. And that's great. But I have to go off and fetch the data again It doesn't come back in the first request, which is not good if you're trying to build efficient and performant APIs that can work with multiple clients and especially over mobile. So this is called underfetching, as it's common terminology. And especially when you get good at the hypermedia constraint of a RESTful API, underfetching becomes a lot more common. So there's a few ways that we can fix this. So one way potentially would be we could put an includes on our URI as a query parameter and include these in our first request. Now this technically is a little bit naughty. It kind of breaks REST because we've added state to our URI. But for this purpose, it works, it solves our problem, and we can get the data back that we need. But there's another problem with this. And that problem is something called overfetching. Now we've got the information that we need back, but we've got way too much information than we need. If we think back to our example, there's not that much information on the screen, really. There's only a couple of properties for the patient summary, but yet if we have a look at the JSON in the bottom right, that's only part of the response that's come back. And the 3 dots at the bottom mean there's a lot more information. So we have this concept of overfetching data and getting more data than we actually need. And again, this is not great for mobile networks. Ultimately, the smaller the payload over HTTP, the better, especially if you want to build efficient APIs. So we can solve this in a few ways. We could technically add a fields query parameter to our URI, and then we could dictate which fields we want to bring back. Now, there's no real standard way of doing this, and there's no real good convention about it. There is various tools that you can use, but when you're dealing with multiple objects and nested associations and lots of properties, your URI is going to get quite big. And ultimately, how do you handle it for other resource types? Because this is just for the patients that we're interested in, but what about other endpoints that we have? It's kind of hard to maintain, and it's an overhead. So something that we could do, and I'll hold my hand up, and I've done it many times, is create an ad hoc endpoint. And this is not the most ideal thing, but what it allows us to do is we can get only the data we need back in a single request. But we've kind of limited now the scope of this endpoint that we've created, because this is just for that specific view. Now, if we had another client, say our initial application was a desktop application or a web application, now we've got a mobile application, how are we going to handle the fact that they have a slightly different need for the way they ask for data? Do we create another ad hoc endpoint? Could do. It's not ideal. There's an overhead in actually additionally adding URIs and maintenance. Or could we create a separate API altogether? Now, Netflix do this, but Netflix do it because they have a very big team and they have a lot of money behind them ultimately, and they can afford to do these sorts of things. This is not always the case with smaller companies. So building APIs today is kind of difficult. As we've seen, there's quite a few challenges that we need that kind of face us, and we kind of need to overcome those. So how does GraphQL fit into this equation? And that's a good question. So GraphQL is a query language at its heart. And this is a fundamental difference between what GraphQL and REST is. REST is an architectural style, and it's a way that we can build APIs. But this is a query language. It's the fundamental difference. They're two different things. But what GraphQL allows you to do, it has a built-in type system. So with this type system, you can define type-safe queries where you only request the data that you want in the shape and format, and your response will mimic that. And that all happens in one single network request between the client and the GraphQL server. So let's have a look. So on the left is basically how we define a type in GraphQL. So we have a patient type. And types are how we describe the data in our application or our API, and that's what we want to kind of expose. Next, we have a query. This is what a query looks like in GraphQL. And it's basically we're asking for a patient with an identifier of the identifier that's provided. And we want this name property back. And if we look at the response brought back is JSON. And it's kind of in the same shape as we asked for it. The only difference is some commas. So that's what technically GraphQL is. It's this query language which allows us to specify queries in any shape and format which are exposed by basically our data object, and we can do that in a single request. So GraphQL is a specification and a standard. It was created by Facebook, I think, in probably 2011, and they've been using it ever since, and they open sourced it back in 2015. It's hierarchical in the sense that it's a graph, and you have objects and nested associations. GraphQL kind of gives a power to the clients. Ultimately, clients specify their data needs. And it's strongly typed. Each GraphQL server has an application-specific type system, which we saw one of the types in the last example. Now I want to talk about what GraphQL isn't, because there's quite a lot of misconception around what it is and what it isn't. It's not about graph databases. Even though it's got QL in its name, it's not about graph databases at all. It doesn't care about your transport protocol either. We can use it over HTTP, and we tend to use it over HTTP, but it's agnostic. It's in the spec. It doesn't care about your data storage. You could use any data storage or persistence you want. You can use a NoSQL database, a SQL database. It's all backed by arbitrary code. And we'll see in the example a little bit later how that makes sense more. And it's not limited to JavaScript. Facebook's implementation is in JavaScript, and that's what I'm going to demonstrate today. But there's reference implementations in pretty much all major languages now. And some are very, very, very polished, like Sangria, which is Scala's version, has a lot of extra features. But there's a .NET version, there's a Java version, Python, there's Go, there's Rust, there's various implementations. It's just a spec at the end of the day. So now we kind of know what GraphQL is and kind of how it kind of works roughly. What problems does it help us solve? Now, if we think back to our example, one of the main problems we had was around efficiency, this concept of underfetching and overfetching. GraphQL kind of avoids this because we structure the data in a way that we bring back all the relevant data we need in the structure and shape that we want. So this is the same query that we would have got in the REST world, but this is what it looks like in GraphQL. So we have a patient, and we have some fields, which is like ID, first name, surname, date of birth. Then we have some nested objects like medications and allergies. But this is all brought back in a single request, and we can write the query on the left to give us the shape of the data that we like. And this becomes really powerful when you have multiple clients. So if you had a mobile application, or you had a desktop or a web application, they can all request the data in the shape and form that you need. You don't have to, on the back end, develop any extra work to do this. Whereas in a REST world, you might have to go to see the back-end guys and say, okay, can I have some more in my resources for patients? Can you add a few more fields? As long as it's exposed in GraphQL, they can query however they see fit. And there's another fundamental difference. With GraphQL, you have one endpoint. It's / usually GraphQL. It's the only endpoint you really have. With REST, you have multiple endpoints for all your resources. With GraphQL, you add objects to your graph, and then you expose them by your single endpoint. So it's a fundamental difference in the way they work ultimately. And it comes to maintenance and development as well, and the development experience is a little bit different, and we'll see more about that in a bit. So what about versioning? And it's quite funny, this actually, because if you go onto the marketing website of GraphQL, it's really, really nice. It's very polished, but it says you don't really need to version, and that's technically a bit of a lie, because you still have to version. But versioning with GraphQL, it forces you to think about backwards compatibility and forward versioning strategies. And it kind of follows the principle what REST technically should follow. It's evolution. And so what I mean by evolution is we're supposed to really evolve our APIs. We can add new fields over time, and then we can deprecate fields we don't use, and then we can monitor the usage of these deprecated fields and then remove them when we see fit. And GraphQL has two really cool features that help us with this. One of them is a deprecated property. So there's some types that's going to kind of roll across the screen in this image. Basically, you can see into the director, it says deprecated. What that actually means is, for all old clients which are consuming this endpoint, they'll be able to still query that and get the data back they need. But any new clients who come on, they will not see that in any of the documentation or any of the IntelliSense because it's deprecated. So that's a really nice way that it kind of handles this for you. And the second part of GraphQL, this versioning feature, is that because you send a query over the wire, you kind of know the shape and the structure and the fields that people care about and what they're using. So you can easily monitor field usage. And then you can say, okay, you've been using this field for like the last 6 months, we're going to get rid of it now. You might want to look at using this other one. So to track field usage compared to, from a REST perspective, where you just get this whole chunk of JSON back and you don't know what fields they're actually using, it's kind of a lot nicer and easier to deal with. So that's kind of how it handles versioning. So introspection. Now this is probably one of my favorite things about GraphQL. What GraphQL means by introspection, it's kind of like reflection for your API. So with GraphQL, you can actually query the schema, the types, and the fields, and you can see what operations you can actually do on this GraphQL endpoint without actually having to do anything other than query the actual schema. And this really lends itself to kind of like building tools. So for instance, if you could query the whole of a schema, you could get IntelliSense and autocomplete because you know what fields are available, you know what operations are available. So IntelliSense kind of comes for free. And you can do things like code generation. Because you know the types, and we've defined the type, say, with our patient type, you could generate code off the back of that by just querying the schema and saying, okay, I know the type's a string, I know what the name is, and I can kind of auto-generate classes in any language that you see fit. So it's pretty cool for code generation. But it also gives you this concept of documentation. Now again, the marketing kind of spiel says that it's free documentation and this is documentation you need for your API. It's kind of a lie again. It gives you this auto documentation about your types and your schemas and your operations, but it doesn't take away from the point that you need documentation for your API. Because the consumers at the end of this is great for developers, but consumers of your API might need more information, things around rate limits, and some of the complexities around your API and how to use it. But this is a tool called GraphQL, and this comes with every GraphQL server. And basically, this is built on introspection. So this example will keep playing around in a loop. But ultimately, if you have a look at some of it, like there's IntelliSense telling us it as a first name. And if we now go look at the documentation, we can have a look at what's on that type, and we can have a look at the surname, and we can add that in, and we can query it. So this is what they mean by auto documentation. It gives you these types and these kind of like query operations. When I first saw this, this kind of what made me really think about GraphQL because there's not many other tools that allow you to have introspection in the same sort of way. And when I first saw it, I was kind of like, damn, that is super cool. At least some people laughed. If everyone's seen Friday, then they'll get that reference. So now we've kind of seen how it works, what it is, what problems it aims to solve for us. How does it fit in the technical stack? Because some people say it's a one-to-one mapping of your database. Now, technically, that's not wrong. You could use it as that, but that's really not its use case. GraphQL sits generally between your transport protocol and your business logic. And as you can see, I've got REST by GraphQL. It's not a replacement for REST. It can work side by side with REST. You can not use REST if you want anymore, but it's not really a replacement. It's an alternative for building APIs. And the two important parts about this diagram is the authentication and authorization. These are not concerns handled by GraphQL. Now, you'll see blog posts about people saying I can do authentication with GraphQL, and that's fine. But generally, it's best practice not to do it. That should happen further upstream. If you're used to anything .NET, like the ID server, you can have an OpenID Connect middleware. You'd kind of handle most of that information. Then you'd pass down the relevant pieces of information to GraphQL, because there is a global kind of context object, which we'll have a look at, where you can get that information passed, again, further down to the authorization. And what we mean by authorization is what can the user do, what fields can they see. And again, that kind of lives with your business logic. It's specific to your domain. It doesn't really need to be in GraphQL. And ultimately, if it was in GraphQL and you had a business logic in your REST API as well, and you were trying to share this logic, then you might have discrepancies between them. So generally, it sits as a kind of a thin wrapper over your API. That's the way I see GraphQL, and that's the way I see it used in many places. And as you can see, persistence is at the bottom. Persistence, it doesn't really matter. Like I said earlier, it's backed by arbitrary code, and that will make more sense when we go through the demo. But ultimately, persistence is just part of your business logic, whatever you choose to use. So now, I want to do a quick comparison between GraphQL and REST. Now, this comparison is not which one's better or which one's worse, and it's not who gets the most tick boxes in each box. It's ultimately to define and illustrate the differences between the two technologies. So, if we have a think about the conceptual model, REST is based on this abstract concept of resources. GraphQL is ultimately a graph. of objects and nested associations. Related operations. What I mean by related operations is, if you was to add an endpoint to a REST API, you kind of know, because we use HTTP verbs in a standard way, what you're going to get when you do a get or a post or a put. With GraphQL, when you add an object to our graph or you add a type to the schema, there's no real way that you could kind of guess that. You'd have to look by introspection to see what are the kind of like, what can we do with that type? Can we insert it, delete it? Can we query it? So that's a fundamental difference between the two. So introspection, which I talked about previously, GraphQL is built on introspection ultimately. REST doesn't really have a standard way of doing this. You can kind of things like tools like Swagger for your REST API, or OpenAPI might have some features around this, but there's no real standard way of doing this, and it's not really mentioned in the constraints either for REST. So data typing. So GraphQL has a type system, and it's strongly typed in terms of its inputs and outputs. REST is weak in that sense, and it's loosely coupled, and it's disconnected between the client and the server. And then real-time. And what I mean by real-time is push-based APIs. REST really doesn't have a way to deal with push-based APIs because it's stateless, and you generally wouldn't use REST to create a push-based API anyway. But GraphQL has something called subscriptions, which allow you to create these stateful subscriptions like push notification style patterns in your application. That's technically not really in the RFC spec yet. It's been floated in and out, but is supported by some of the external libraries. But it's not supported in the one that I'm going to demonstrate with Facebook's GraphQL implementation. Well, not yet. It's supposed to come probably the next month or so, but it's not here yet. So now we've got an understanding of what GraphQL is, what it does, what it doesn't do. Kind of have a look at some of the core concepts of what GraphQL is in a little bit more depth. So I've broken this into 3 different areas. So the first being the type system. So the type system generally defines all our objects that we can query on in our API. Then we have operations. GraphQL allows you to query data, also allows you to mutate data. You can do inserts, deletes, and and writes. And also it has subscriptions. And then the schema is kind of the glue that holds all this stuff together. It's kind of like the entry point into your graph of how you can query the certain fields and what, when you do query these fields, what happens and what response do you get back in terms of the type. So types are on the right. We have a medication type and a patient type, and we call these object types. And most of your GraphQL API implementation will generally be around object types. So we've got some properties, or they're called in the GraphQL world fields, which are like ID, identifier, first name, and surname. And then we have these backed by scalar types. So you've got integers, strings, booleans, and floats. And you can create your own scalar types, so there's extensions for that. The type system supports enums. So if you've used enums in any major language, it's technically the same. It supports lists. So as you can see, we've got a medications field, and the medications is basically denoted by an array, so the square brackets around it. And there's actually an exclamation mark on the identifier next to the string. I just want to point out that means it's non-nullable. And also, types support this concept of interfaces. So interfaces are just like you used in C# or Java. It's allowed you to share common fields between types. And unions are kind of like interfaces, but they don't share any common functionality in terms of fields. So the resolve function. Now, technically, this is where all the magic happens. So on your left, we see this is how you implement the actual type in JavaScript using the Facebook implementation. So we have an object type, which has a name of patient, a description, and we have some fields, and we have this name field. But the most important thing about this is that all the fields in our type have a resolve function. And this resolve function is where we call arbitrary code to actually resolve that field. So for instance, name is just returning a hard-coded string of Tony Stark. But in the real-world example, you might have this mapping to another object. You could call your business logic, could call an existing REST API. You could pretty much do anything that you'd want in a normal. It's a normal function. So anything you can think of returning static data, it can do that. And this is generally where the magic happens in GraphQL. what happens is you send a query, ultimately it gets executed, and it goes through and it recursively looks at all the fields and looks at all the resolve functions, and then it basically executes each resolve function in parallel. So this is where kind of our logic lives. So operations. So we've talked a little bit about queries. I just want to kind of go through another example of queries. So queries allow us to retrieve data. So this is graphical, and I've got an example of a query. So to create a query, we use the keyword query, and then we have a name which is optional. We don't have to have the name. We can pass arguments to queries, and the brackets between the ID and the closing bracket is basically called a selection set, and inside of selection set is the fields that we care about. And then we've got medications, which is a nested object. So that's generally how we're going to write queries, and that's how you'd kind of structure them if you was going to call it from an external source like Postman or make a HTTP request over to your GraphQL server. So mutations. So GraphQL is not only about reads. A lot of people use it for reads only, and it's very good at that, but you can actually mutate data. You can insert, delete, and remove. But mutations are kind of like, it's like a bolt-on, I always see them as. They don't feel as natural as queries, but they're kind of an RPC style in terms of their naming. So we have a mutation, we have the mutation keyword, and then we can give a mutation a name, and again, that's optional. But you can see the input now is actually an object, and this is a special thing about mutations. You can feed in a complex object, which is different to the type you're returning. So it's a concept called an input object. So if your data is structured in a different way than you return it, it allows you to have this clear separation between the two. Mutations always have to return something. They have to return a type. So in this scenario, they're returning the patient that we just added to the system. And that's useful for when you're doing any further pre-processing. So the schema. So as I said previously, the schema is kind of like your entry points into the graph, and it's basically how we can see which fields we can query on and what they return. So this is how you define a schema. So it has three properties. There's query, mutation, and subscription. Queries are mandatory in any GraphQL schema. You have to have a query. Mutation subscriptions are not. You don't have to implement them. They're just extras ultimately. So what we have here is we have a query and an object type. And if we look at the fields, which is the most important bit, we have this patient. And the patient is what we're actually going to query on. So if you think back to what was in the previous example, we was querying on patient. And the argument was the NHS number. And the NHS number is just a unique identifier for people in the UK who are in hospitals, and you get that when you're a child. But you see the resolve function here is actually calling a database and getting a patient. But if you look at the type, it is the patient type we created earlier. So ultimately, what's going to happen is, if I search for patient and pass in the NHS number and pick the field of the patient, that resolve function is going to get called. And that's what goes off and makes a database call. Or it could make an API call. But in this instance, it basically goes and gets the patient information. So we've kind of had a look at all of the core concepts and what GraphQL isn't and what not. Now I want to kind of jump into a demo and kind of go a little bit deeper with this and kind of show you how to create like a GraphQL API from scratch. So first thing I want to do is there's two parts to this. There's a single page application, which I'll show you now. So we have this very simple Angular application. It's built with ASP.NET Core as its host, and it's using Angular 2 and TypeScript, I think. And its Webpack is going to be doing all the bundling and kind of the auto-refreshing you'll see, or hot module replacement as it's called. So we have this home screen, and we have some patients. So this is kind of like the demo that we saw right at the start with our mockup, where we're going to have a list of patients, and then we can drill down to these patients to kind of see a patient summary. And then we have our GraphQL server, which currently is a simple web server. And this is just basically a Node.js web server. It's an Express server, but it runs on Node.js. So the first thing we want to do is I'll have show you around the structure. So the client is just basically very simple. We have a client app, and inside the app we have a bunch of components. And there's nothing really particularly special about this. And then if we have a look at the server is our GraphQL endpoint. So we have the server.js file, which is kind of like our entry point. And we have the schema folder, where I've kind of broken things up into mutations, queries, and types. And we have the schema.js. We have kind of a database context, which is currently empty. And I'll just show you the database that we're going to use. So the database is a NoSQL, a SQLite one. I can't actually zoom any further into this because this application doesn't allow me to do it. So there's two tables, patient and patient medication. That's ultimately, it's a very small database. So if we go back, the first thing I want to do is have a look at the server. That's the wrong file. So basically, this is a very simple Express server. I've imported all of the things that we're going to use because I didn't want to download them and kind of install the packages because that's kind of a waste of time and it's not really what I want to show you. So currently, as you can see, any request that comes in is just going to return this simple web server. I've actually installed the Express GraphQL, which is basically our middleware and the reference implementation for GraphQL in JavaScript, and it's written by Facebook. So the first thing we want to do is we want to add our GraphQL endpoint. So we feed in the schema, which is currently empty, but we've set GraphQL to true. And GraphQL was what I was saying before was this tool that was built on Introspection, and you've probably seen it in some of the examples. So the next thing we want to do is we want to kind of define the type, because currently this GraphQL server is useless and it'll just throw an error because there's nothing in the schema. So we want to first define our structure, and our system is around it's a medical API, so it's around patients and medications and allergies. So if we have a look into our patient, we can add a patient type in. So basically, I've imported all the types that I'm going to use, so the strings, integers, booleans, floats, lists, enums, and object types. And all we have done here is define our object type. And this is basically a very run-of-the-mill object type. We've got some fields, ID, first name, surname, date of birth, and NHS number. So that describes our data, but how can we actually query that, and what are we going to get back when we want to return this type? So what we're going to do then is we're going to actually add in the resolve function. So I've imported the patient, and this basically gives us our patient type, and I've basically added some description, which we'll see in the graphical document editor. And then here's the most important bit, is this resolve function. So this resolve function, currently I'm just returning some arbitrary data. It's just basically a JavaScript object. So now if we implement our schema, so all I've done is say, okay, when we search for this field's patient, then we're going to basically go back to our patient query we created, and it's of a patient type, and this is what happens when we resolve it. So I've got node monitoring in the background, so it's kind of like rebuilding the server all the time when I change a file or save a file. So technically, if we go back to here and have a look, we should see a GraphQL endpoint. We'll get rid of this. And if we have a look in our documentation, we have this root query type which we created, a patient. We have a patient type. And now if we used to write a query against this patient, we can see we get IntelliSense. I have to feed an NHS number in, but I can put in anything because I'm not using that in the back end currently. If I type in first name, we should see the static data that we get back. So this is the test patient. Now, that's basically it. That's GraphQL summed up in a T in terms of its query language and how to set up a GraphQL server. Everything else now is just fleshing and embellishing the kind of structure that we've made. But ultimately, you add a type in, you have a schema for your entry point, you say how you're going to resolve this, and that's generally just rinse and repeat. That's the kind of pattern that's used. So next, what I want to do is I want to add actually in an enum, because as patient, we need to know the gender. So if I go to types, I'll create this separately. We have this GraphQL enum type, and basically this value, and value 1, 2, and 3, what it generally means is it's just mapping in the database. In my database, I've got 1, 2, and 3 as my kind of indicators for this enum type. So what we can do then is we can import it into this file, so we can actually use it as a type, and then we can add this to our, So we've added the gender in, and we've used that gender enum. Now if we go back, let's refresh this. If we look in here, we should see now we have gender. And if I was to put gender in, it's hard-coded to 1, so we'll see male. So now we've kind of enriched our data model a little bit more. What I'm going to do now is go back a little bit further. And we're actually going to connect now to a database and actually show you something a little bit more meaningful than other than an arbitrary code-backed resolve function. So the first thing we need to do is go into the server. And I've created this kind of like concept of a DB context. So if you're used to Entity Framework or anything like an ORM, I've kind of just mocked my own version of it. And what I'm doing here is passing in this SQLite library, which is basically how we communicate with the SQLite database that we have. So inside our DB context is currently empty. So what I need to do is I will need to add in the query. So this is how we query to get a patient. It's very simple. It's just a simple db.get, pass in the NHS number, and just return back a certain set of fields. So now we actually need to change our resolve function. But before we can do that, we have to add some boilerplate code in. Because we currently don't know about this DB context anywhere, so we have to kind of pass it around or pass it to GraphQL to pass on to our resolve fields. So what I've done here is there's a DB context as a parameter, and this context object is a special object. It's a global object that you can pass information to. Every time you run a query, you can pass the state of your environment at that point to this object. So you can have things like authentication viewers and things like that, so you can read about their permissions and so on and so forth. So I'm just passing the DB context every time we do this. So now what we need to do is just quickly bootstrap the application because we're using SQLite. So all we're doing is opening a database connection once the application runs. We're kind of setting a trace on the queries that are coming, that we're executing, any errors, and then if it's all good, we kind of launch the application again. So now we've kind of implemented most things, we have to change our resolve function. So currently, we have this arbitrary code that returns us back an object. Now we actually want to call that database method. And so ultimately, we pass this context through. And we've got this DB context, get patient, get NHS number. So now if we go back, and I was to refresh this, and try query, it comes back as null, because now we're actually calling the database. We're not using that test data. So if I was to go steal an ID, and put this in its place, then we have basically a connection now to the database, and that's how you can pass information around. So now we've got the basics, and we've got our connection to the database established. What I'm going to do is add in the medications, which is kind of like what we've seen before. We first have to add in a type. So we have a medication type, which has basically got a couple of fields on it. And then we have to have a way of how we're going to query this from the database. So it's just a simple view. We get back all the medications by patient ID. And then to actually expose this as our data structure, we actually need to add this type onto our patient, because it's actually a nested association. So we'll import that. Scroll down. So now we have these medications. And interestingly, we're resolving these on this type. We're not resolving the patient query, because you can resolve fields at any level. As we've seen, every field has a resolve function. So now, if this actually worked, and I go back and I was to refresh this, if I was to type in medications, now we have a nested association. I can type in, say, the name of the medications. And if we close this, we've kind of got now our association. So that's kind of how you build up your kind of data source, or the data that you want to expose to the server, to the end client who's consuming your GraphQL endpoint. So now we've kind of looked at queries. I want to look at mutations. So I've already created an add mutation file. So the first thing I want to do is to actually add in the input type that we care about. So as I discussed previously, you can have a separate GraphQL input object type. Usually you see the object type, but the input object type is a complex type that you can use to pass to your mutations. It doesn't have to marry up with your patient type. So basically, I've added that, and what's going to happen here is, this is how we're going to add the mutation in. It's going to return a patient type, and the resolve function is going to actually add this patient. This patient, when we add it, we actually return back the one we've inserted, because our argument input takes in this patient input type above. So if I was to change the database context to actually have a real implementation, let's see if I can format this. Kind of did something. But basically, we're inserting the patient and we're returning the patient back that we've just inserted. So now we need to add that to our schema. Currently, the schema doesn't know anything about mutations. It only knows about queries. So we need to give it like an entry point. So as we can see now, we've got this add mutation, which is imported. And similar to how I have the root query type, we have our root mutation type. And when we search for add patient, it's going to run the mutation that we've actually just created. So now, if we go back, let's refresh this, just to remove it, that mutation. I can do add patient, and you'll see now this is actually a complex type. So if I do first name, I have to fill all this in. I've got surname. So actually, this is interesting. So I've just filled these in now, and it's still got red squiggles under it. This is what I was referring to when we talk about validation. It basically says, the first name, surname, test. It says, there's an HS field, which we need to supply, and it's expected because it's non-nullable. So if I supply this, 1, 2, 3, 4, and now I can change the first name, because we have to have return type. Execute that, we have that, so let's just show it's not smoke and mirrors. And at the bottom we've got a ninth one, which is test and test2. So that's generally how you handle mutations. So we've kind of nearly come to the conclusion with our GraphQL endpoint. But we have one last query that we need to run. If we think back to our application, then we have this patients list. We currently don't have a query to kind of give us that information back at all yet. But because we've defined a type, and we've done a lot of the boilerplate, it's fairly easy to add in. So the first thing I'm going to do is just add a query in of how we get this information from the database. Nope. So all we have here is get all patients, and basically it's a DB all, and it'll return everything. Now if we come across, have a look at our queries, we can add a query in to actually handle this. So what we're saying is, when we type all patients in our query, we want a list of the patient types, which we've already defined, and then we want to call our database context. So if we go back and we refresh this, type in all, interesting. Right, so as you've seen, this is highlighted something. You can add associations, and you can add types, and you can do all this database stuff, but you ultimately still have to define it in the schema. Because I didn't actually add this into the schema. The schema has no way, currently all it cares about is patients in the root query type. I've defined everything else, but I haven't added it actually to the schema. So that's why when I was typing, I didn't see all patients, I didn't see anything. So what we have to do, we have to add this into the schema, and now it's exposed to basically our consumers of our API. So now if I was to do this, and all patients, we can see all the patients. So I can do first name, and then I can do, say, get the medications, get all the name of them. And that's kind of fulfilled everything that we need to do for our UI. But there's one problem here, and some of you might have noticed it, or you might not have. If I just bring up the console, I'm actually logging the SQL queries. And if you look, what's happened is, it runs one query to get all the patients, but then it runs each resolve function individually for its medications. That's not good. My database is really small, so it looks fast and quick. In the real world, you'll get punished for that, unfortunately. I can get away with it here, but it's not really a performant way of doing it. So there's something called data loader. And data loader allows you to batch up basically a bunch of IDs and run all of those IDs in one request instead of adding them individually and running them against each resolve. So what I'm going to do is we're going to actually fix this. So it's fairly trivial to fix. So the first thing I need to do is I need to add in Lodash, which is a utility library, because I'm going to do a group by, and I'm not going to write that myself. And so what we need to do is, because our query is by ID, I need to change that to kind of an any or an in. So what we've got here is I've changed this query so it'll take in like a comma-separated list now. And all this query is going to do is going to group by some fields, so the patient ID, and marry up the patient's medications with the correct patient. If it doesn't have any medications, it will create an empty array. So that's pretty much the query end of it done. But we need to change the server slightly, because data loaders, we run per request. So basically, when we make a query request, it's going to come into this endpoint, and we're going to create this new loader every time we do it. And it's called patient medications, and this data loader is going to execute our get patient medications. That's ultimately what it's going to do. And that's the query that we've kind of changed in our database context. But as you can see in the context object a little bit further down, we're actually now passing these loaders through. So we can pass these loaders through to any resolve function now that we need to do, because it's globally available. So that's kind of the boilerplate done. So in the patient query, in the type for the patient, instead of resolving them individually, we can use our loader and call the load function. And basically, it's going to batch up all the patient IDs. So now if I was to go back, rerun this, query still works, still got the same data. But now if we have a look at our query, oops, we only have 2 now. We don't have the same, I think, there's 9 before. And you can see it's actually got an in statement with all the IDs. So this is one of the kind of things that I'm going to go into the considerations a little bit further on, around how you have to be careful about optimizing queries, because you can get burnt quite easily with the simple resolve functions that are available, because they're executed all the time. So as you saw, if you had nested lists and you didn't have a loader, you would basically execute that every time that you're calling its parent. So you've got n+1 problem. But that's generally our endpoint created. We can do mutations, we've looked at schemas, we've looked at types, we've looked at queries. Now, how do we actually hook that up to anything that's of any value other than Postman? So in our client, I'm actually using a GraphQL client called Apollo client to kind of handle the calls for me. So I've actually imported all that, and it's basically this library called Apollo Angular. So what that technically does, it gives you a lot of stuff around batching and caching, so you'd have to implement it yourself. And so if I was to change this, so what we're doing now is we have basically a query to our Apollo client. We structure our query, which is passing in the query that we've seen in the graphical, and basically we're going to get the object back, and we're going to assign it to one of our patients. It's just basically a type that I've created. So now technically, this actually does work, and I go back, you should see it's automatically populated with some patients. So that's basically made a call to our GraphQL endpoint. And we've got the data that we need. And there's no overfetching, there's no underfetching. We've literally specified all the information that we want. So now if we click through, because we've defined all the data structure for a patient, we can actually fill this patient summary in quite easily. So if we come across and have a look at our component for patient summary, all I'm doing again is I'm taking the ID from the URL, and I'm structuring this query, passing the ID for the NHS number, and I'm getting back all the information, like the medications. I'm basically assigning it to our patient object. So I pass the medications down. I actually make the call for it in its parent, and I pass it down to patient medications component. So basically it's using the input type, which basically passes it from its parent. So I've just got to uncomment some markup. Now, if we go back, technically we should see that we've got the patient summary and we've got medications. Just to prove it actually does work, we can click on any of these. And this is actually all cached now. Because we're using something like an Apollo client, it caches the data, and there's very clever things that you can do with caching and batching. You can vary on ID. But that's ultimately the demo. So we've seen all the core concepts in action. We've kind of had a deep dive of how to create a query, how to do mutations, what's the schema, what's the type, and kind of seeing how we can use it with a real-world application. Now, bear in mind that application is very, very simple, but the actual implementation is will be kind of what you do anyway. It's just the basics. Now I'll have a look at some of the considerations of GraphQL, because GraphQL is not a silver bullet. As you've seen previously with the performance issue, there's other issues that you need to be aware of if you want to use GraphQL. So, first one's around caching. With a GraphQL, you can only cache in two places. The application server, which is a GraphQL endpoint, or the client. And you're hoping the client caches, but that's not mandatory. You can't use network caching anymore like you could do with REST APIs, because what you haven't seen is when we're actually making requests to our GraphQL endpoint, we're posting the body to our GraphQL endpoint. Our requests are no longer idempotent. We can't cache it. We can't use network caching. It's not a GET request or anything. So we kind of have two options here. We have to implement a cache in our backend, which would be between our business logic and our persistence. It would be kind of like a read-through proxy. So we check that first, and then we would, if it's not in the cache, then we'd go get it from the database. But on the client, we'd create something called a normalized cache. And the normalized cache is created by the Apollo client, and it's created by Relay, which is another library. But if you want to roll your own, ultimately what the normalized cache does is, instead of saving the response that we get back, as is, it flattens the structure of it, it normalizes it into a collection of rows, and then gives each row a unique ID. So then you don't have data duplication of the same patient in the cache, and so on and so forth, and you have this single source of truth. So that's what I mean by a normalized cache. And if you use something like Apollo client or Relay, that's something you want to look into, because they kind of give you that for free. Otherwise, you're going to have to write that. And I've seen, I think Spotify wrote their own version of it in Python to kind of help with some of their stuff they was doing with GraphQL, but you have to kind of roll your own. So another consideration is around performance, what we saw. You kind of have to be careful of your queries and mutations and how to optimize these things. Because ultimately, as you saw, we could run into this problem of n+1. And unlike with the REST API, where we have this URI and we have this endpoint, it's much easier to track down where our poor queries are. You can kind of look at the endpoint, trace it through, and say, okay, this is a query that's run. Because these field resolvers all run in parallel, and you can have resolvers nested within resolvers, tracing the queries is a little bit more difficult, so you have to plan your data structure up front. So as you can see, one of the solutions for this is loaders, and loaders exist in pretty much all languages now. It's not typical of just the JavaScript world. I've seen a .NET one, I've seen a Java one. So security. The basics about security is don't expose anything that you don't want to be public, ultimately. That's the premise of it. But because we have this endpoint where people can query in any shape and form, and they can do nested queries and so on, it kind of opens us up to a world of malicious queries. So there's a couple of ways to handle this. A very simple way is to use timeouts. If the query takes too long and you know roughly how long your query takes, you can kill it and say, just don't do anything else, and return an error back. Or a more in-depth ways, without hitting the database, would be, because we know the query and the structure that's sent to the GraphQL server, we can do some analysis and query depth analysis, basically. We can have a look at the query and say, if we've got medications nested twice, we can't do that. And we can return in a validation layer, so it's much further up in the execution chain. And that's a little bit more involved, but it's generally more valuable. Then there's error handling. If you're used to REST APIs, you can't really use HTTP status codes with GraphQL. It gives you back a 200 for an error, because GraphQL's errors are actually inside the resolve function, and it's a property that it gives you back. The response will be error. So if we quickly look at our GraphQL server, you'll see exactly what I mean. So if I was to type some rubbish, you get errors back. A lot of times you'll get that back as a 200. There's scenarios where you might get it back as a 400, but you can't rely on status codes anymore. So what you have to do is, inside the resolve functions, you can throw a GraphQL error, and then you kind of just structure your error in a certain format, and you display it using that. So they have to check the inner response object. You can't rely on status codes anymore. So when do you want to use GraphQL? And this is probably the ultimate question that I get asked quite a bit. And this comes down to, like any other technology, you kind of have to have a specific use case for it. If you have a really highly queryable API that has a lot of different clients, have different data structures, and they want to kind of have it all in a single endpoint, it works well with that. But if you've got a REST API which follows good practices, it's not a case of just jumping and moving from one to the other. You kind of have to find the middle ground. And like with anything, you're going to have to test it and see if it's going to work with your business and your data structure. So now it's got some resources. So these resources are generally, The GraphQL website is really, really useful in terms of its marketing spiel, but the documentation behind it and the specs really cool. Awesome GraphQL, just a set of links. Apollo client is what we kind of implement the client with, and then I've got my application if anyone wants to look at it. But the most important one is if anyone's interested in playing with GraphQL and doesn't want to stand up a server, the bottom one is created by Facebook. It's a Star Wars API, and it basically gives you graphical, and you can kind of do some queries, and you can put a front end on it. You can do pretty much whatever you want with it. And it's definitely worth if you don't want to get involved and create your own. So that's basically it. Thank you very much for your time. And if you want any questions, just come up to me afterwards. Yes.
Could you and should you look at queries and only request from the database what you need?
Right, so there's a couple of ways to handle this. There's something called SQL join monster, which will take your query and it'll basically write in SQL. So if you specify the only columns you're interested in, you'll do select, say, first name and surname, you won't get the whole object back. So there's ways to handle this. But ultimately, for my naive example, yes, I return the whole data set, but you'll generally have to kind of limit that based off the query that you have, either using a tool like SQL Join Monster, and there's one for Postgres, or you kind of have to roll your own. But yeah, generally, you've moved overfetching in that sense, that you've basically moved it just to the server.
Right.
So.
And one other question, it seemed like I was expecting you were going to have to do a join in your SQL query, but I suppose you were fortunate that both tables had the same key that you could query on, but wouldn't you sometimes have to do a join in the SQL yourself?
Yeah, you can. So a SQL join monster, literally in its name, will allow you to basically, it does a left join in everything that it thinks is a nested object, and it'll try and marry up the IDs. But yes, mine was a very simple example. I had a view that wraps everything up. So that's why it was a single statement.
Does
Paging. Yeah. Well, paging for GraphQL doesn't exist. This is another caveat, unfortunately. You don't get paging. Like with OData, you get paging. You don't get it with GraphQL. So you see I pass in arguments. You basically pass in, like, say, a top 5, and you handle that yourself on the other end. They recommend you using slicing, but you have to write all the logic yourself. It's in their best practices as well. They don't have anything built in to support paging. Now, this is really, Facebook actually do paging, but they have not open sourced their paging aspect of it. So you have to manually, however you want to do paging, if I was to feed and say, we can feed 2 arguments saying skip and take 10, then you basically have to manually pass that to your arbitrary code at the back to handle it, and you handle that yourself. There's nothing in GraphQL that says, okay, oh, you're doing paging, let's help you out. No, unfortunately, there's not. Yep.
Can you use GraphQL as an, let's say, API aggregator?
Yes.
Is it a valid use case?
So Thomas Cook, the flight company, used GraphQL as an aggregator over their serverless stuff. So they have GraphQL and like Lambdas as well. But it's a general scenario that you'll see is if you have a load of microservices and an API gateway that sits in front, you can put GraphQL in front of that, have your data structure call all the API endpoints you want, and basically the client is only caring about the GraphQL implementation, but at the back you're just resolving each one separately. That's used in a lot of places as an aggregator.
Right, so basically, do you need an API gateway in that case? Or
You technically don't have to have an API gateway. So you can bypass that and in your resolve function, call your Lambda function separately if you want, or call your REST APIs where information lives, and just return a single endpoint. So you don't have to have the API gateway. Some people put the API gateway in for other reasons around authorization because they don't want to handle it. So they do that at a much further layer. But yeah, that's an aggregator is a very valid use case of it. And there's quite a few companies which have not come to the kind of like table and said that they're using it, but in the background I know people who are using it, like Thomas Cook's a good example, they used it. You're all free to go then.